section 17.2, what we can start to talk about is now we know what waves are. How do we describe how waves are moving? So we can make a couple calculations about waves based on a variety of things. And one of those calculations that we can make is frequency and period. So a wave is going to repeat itself over time. All right, that's a given. It is going to repeat itself over time. So what we can do is we can measure how often it repeats itself. And if we measure how often it repeats itself, that can give us some information about the wave. So we know that a wave goes up and down, up and down, up and down. Right? Essentially, that's what a wave does. A wave continues to go up and down, up and down, up and down. If we measure one cycle, that is called the period. And the period is the time to do one cycle. So a period is the time required to complete one cycle. So the up and the down is one cycle. This would be 2 cycles, 3 cycles, 4 cycles, 5 cycles, 6 cycles. See how it continues to repeat itself? So that's the period, the amount of time it takes to go up and down in one time. Frequency is the number of up and downs in a given amount of time. Typically we go, how often can that wave go up and down in 1 second? So if that wave can go up and down 3 times in 1 second, 1, 2, 3, all right, if this blue is 1 second, we're going to refer to this wave as its frequency. Now frequency has a cool unit. Right? Frequency is measured in hertz. So if this wave goes up and down 3 times in 1 second, 1, 2, 3, the frequency of this wave in the blue box is 3 hertz. So that's the frequency of the wave, how often it goes up and down in a given amount of time. So we'd like to measure a wave's frequency. So frequency is usually how often it can go, how many times does it go up and down in 1 second. Frequency applies to your everyday life. Right? When you tune into the radio and you're listening to 106.9 KROC, that radio station is 106.9 megahertz. Right? A megahertz is 1,000,000 hertz. So you're listening, that radio frequency is 106.9 million hertz at any given time. So frequency. Right. What else can we measure? Well, this is going to be expanding upon what we talked about. All right, so you can see 2 types of waves here. On the top, we have high frequency. Why? It's going up and down more. On the bottom, we have a low frequency wave. Why? Because it's going up, then down, then up, then down. All right, it's taking some time. Whereas the one on the top is going up, down, up, down, up, down, up, down, up, down, up, down, up, down. So it has a higher frequency because the wave's going up and down more, where the bottom one is going much slower. So we can talk about wavelength. And here's our symbol for wavelengths. It's an upside down Y, pretty much. It's a Greek letter. We'll talk a little bit more about it. But wavelength, we've talked about wavelength already. It's the distance between 2 points. And the easiest way to measure wavelength is go from crest to crest or trough to trough. And since it's length, what are we typically measuring our wavelength in? Meters. However, when you measure the length of a wave, you're going to see like times 10 to the -7, -8, -9 meters, because wavelengths are really small, because most waves are really small. So wavelength, we've touched on this one as well. Amplitude. Amplitude is essentially the height of a wave from its rest point. The more energy a wave has, the higher its amplitude. So you have the wave in blue. I'm going to give you the same exact wavelength and frequency, but I'm going to give you a higher amplitude in green. So the green wave has more energy, whereas I'm going to do a red wave, which has less energy. because its amplitude's not the same. So the amplitude's the height from rest position. This black line going across is its rest position. The higher the wave, the higher the amplitude, the greater the energy. Last thing then, and this is what's really cool, is that if we combine the two things that we talked about, wavelength and frequency, we can figure out the speed of a wave. So we're going to take the wavelength in meters. We're going to take the frequency in hertz. We're going to multiply them together, and we're going to get velocity. Now, what is our unit for velocity? It's still meters per second. So we can take this equation, and we can figure out the speed. Now, most waves travel at a constant speed. So, for example, sound in air travels at a constant speed. Light in outer space travels at a constant speed. So, if we're talking about speed, let's do this question. All right. What is the speed of a radio wave? So we talked about radio waves. All right. And we're going to focus specifically on KROC. What is the speed of a radio wave that has a length of 2.80 meters and a frequency of 106.9 megahertz? That would be KROC's radio station. Now, megahertz is 106.9 million hertz. So, really, megahertz is going to be, if we rephrase this, our frequency. Our frequency is going to be 106.9 hertz, like that. Our wavelength is 2.80 meters. Now, we talked about that a lot of times your wavelengths will be times 10 to the negative 7th, 8th, 9th. Radio waves are fairly long, so that's why they're 2.8. So we plugged in everything that we have. What is the speed of a radio wave that has a length of 2.8 meters and a frequency of 106.9 megahertz? Well, velocity is equal to frequency, or wavelength times frequency. We're going to plug everything in. 106,000 or 106,900,000 times 2.80. Going to multiply those together. Now, what's critical here is your sig figs. How many sig figs do we have in the problem? Well, our wavelength is 2.80. How many sig figs does that have? Correct answer, 3. How many sig figs does our frequency have? 4. So we're going to go 2.80 times 106,900,000. And we're going to get 3 sig figs as our answer, and our answer is going to be 2.99 times 10 to the 8th, and our unit for velocity is always meters per second. So, when we start calculating things about waves, we can start talking about velocity, and velocity is equal to frequency times wavelength. Remember, wavelength is just how long a wave is. Frequency is how many ups and downs we get in a given amount of time, and the unit for frequency is hertz, and the unit for wavelength is meters, and our velocity unit is, again, meters per second. This concludes section 7.2. This is Mr. Kleinert. I'm signing off.